Hello everyone. Today we will be talking about a problem from series and parallel AC circuit. This is the problem. Here we have to use complex algebra to find the equation for I, and we have to sketch V and I. This problem is taken from Introductory Circuit Analysis, which was written by Robert L. Boylestad. Before going into the solution, we have to find the impedance of the circuit. Here we have only one element, that is a resistor. The value of the resistance is 5 ohm and the voltage is given V is equal to 100 sine omega t. As we know, resistor do not introduce any phase difference between voltage and current, so theta r is equal to 0 degree. This is the equation of impedance for resistance. ZR is equal to R angle 0. Now let's see the solution. At first, we need to process the voltage equation. We need to convert it to the phasor form. The phasor form, capital V is equal to 70.71 volt angle 0 degree. How we got that? We divide the 100 by root 2 and got 70.71 because this is the RMS value. Since we do not have any angle with omega t, so the angle is 0. Now capital I is equal to V divided by ZR. So 70.71 angle 0 degree, 5 angle 0 degree gives us 14.14 ampere angle 0 degree. Let's see the calculator and calculate this. At first we need to change the mode to complex. This is a must. Then we will put 70.71 angle 0 degree divided by 5 angle 0 degree equal. This gives us 14.142. Since this thing do not have any angle with it, so our final angle will be 0 degree. So our small I is equal to root 2 14.14 sine omega t. Since the capital I was 14.14, so it should be multiplied with root 2 to get the maximum value of I, that is Im. If we further calculate, the value becomes 20 sine omega t. Since it was a resistor, so it will not introduce any angle as we see earlier. So the equation will be 20 sine omega t. There is one more solution available to this problem. Let's look into that. V is 100 sine omega t. So we will directly convert it to the phasor form. We will not convert it to RMS. So 100 angle 0 degree. So the small I is equal to small v divided by ZR. That is 100 angle 0 degree divided by 5 angle 0 degree. That gives us 20 angle 0 degree. So our equation is 20 sine omega t. Now look into the waveforms. These are the waveforms of V and I. The bigger one is the waveform for V. The smaller one is for I. As we can see, they started at the same point and they ended at the same point as well, since they didn't have any phase difference. That's it for today. See you in the next video.